constant throughout the motion. In a rigid body, the distance between any 2 points is fixed. Suppose this any 2 point is distance is fixed. So how you define the degree of freedom of a rigid body? Suppose let's say we know that suppose it contains one particle. Suppose the rigid body contains one particle, let's say A. So how many coordinates are needed to specify its position, which is called degree of freedom? Hello?
Three. Three.
3. Yes, 3. Suppose we take another particle B. So how many extra needed? 3. But if it is a rigid body, the distance between two is fixed.
So
Okay.
only three is needed, sir.
No. For A we need 3. For B we need 3. But when it is a rigid
Five,
body, if
five,
we join them, instead of 3
five,
plus
sir.
3 is 6, there is a constant. There is a relation between them. Okay, so one is decreases and we need only extra 2 for B, not 3. Because B is connected to A. Suppose it is connected to X axis, so X coordinate of B can be determined from A. If distance is 5, if X coordinate is let's say 2, then obviously X coordinate of B is equal to 7. We have to only determine the Y and Z. So we need extra 2 points. Similarly, if I take C, actually there are 3 points to be needed, but if the distance between them is fixed, means distance from A to C is fixed, distance from B to C is fixed. So two relations are exist. So only extra one coordinate is needed for C. Okay. Similarly, if I bring D, it needs 3 coordinates, but since it is related with A, B, and C, so we can determine the position of D from the knowledge of A, B, C. No extra coordinate is needed. Similarly, if we add E, F, G, 100 number of particles, then no more coordinate would be added. For A, we need 3. For B, we need 2. For C, we need 1. For D, E, F, anything, we need 0. So total is equal to how much? 6. So for a rigid body in 3 dimension, actually we are considering everything 6 dimension. Actually 3 dimension, only 6 degree of freedom or 6 coordinate are needed. Clear? Are you getting my point?
Yes, sir.
Okay. Suppose a rigid body is placed in a 10-dimensional space. Number of coordinate depends on dimension. Suppose if it is a 2-dimension, we need only 2 coordinates for a point. Suppose on a wall, a ant is moving on a wall, so we need only 2 coordinates to determine its position. Okay. When bird is flying, we need 3 coordinates because the 3 space coordinates comes to picture. So if it is rigid in 2 dimensions, so for A we need 2, for B we need 1, for C we need 2, 0. So it is on 3. If dimension is not given, we assume it is 3-dimensional and degree of freedom is 6. If let's say question is in D dimension, then the first particle A, how many number of coordinates are needed? If it is D dimension, then
D.
D, yes, we need D. For second one B, we need D, but A and B are related.
D minus 1.
Yes. Similarly, for next D minus 2.
2.
Okay. Up to
D minus D. 0.
D minus D 0. 2, 1, you can write 0. So this equal how much? If you add this, it will be 1 plus 2 plus 3 up to D.
D into D plus 1 by 2.
Yes, D into D plus 1 by 2. So for rigid body in D dimension, degree of freedom or number of coordinates required to specify the configuration is D into D plus 1 by 2. Here, actually here D is equal to 3 for space. A normal case, we consider space, D is equal to 3. You put 3 here, 3 into 4 by 2, 12 by 2 is equal to 6. Okay. So for rigid body, degree of freedom is 6. Clear? Hello?
Yes, sir. Yes, sir.
All are written in here, the description, what I tell, written here. The degree of freedom of rigid body and D dimension D plus 1. Okay. So for 6 coordinate actually, to establish the position of one reference point, the 3 coordinates must be served. For 6, for rigid body dynamics, we need 6 coordinate, and actually how we define the 6 coordinate, we take a reference point inside the rigid body, and we assume that that reference point is the center of a coordinate axis which is known as body set of coordinate. And outside is there is a space set of coordinate our normal, but we have to find a point. Generally, if any specific point is not given, we take it as the center of mass or center of gravity point. Okay, but otherwise we have to take a reference point, and a reference point is the origin of a body set of axis. It is another Cartesian coordinate system which origin is at O, reference point. So if you know the origin, it has 3 coordinate of origin, we need 6 coordinate. If 3 are come here and 3 are rotation of the that body set of axis with respect to space set of axis. For a rigid body dynamics, we have to set a axis inside the rigid body coordinate axis, okay, which is known as body set of axis, and we first want to know the position of its origin, which is called reference point. In general, we take a center of mass or center of gravity point. Okay, it has 3 coordinates. For 6 coordinates, 3 are for the coordinates of the origin and 3 are the angle of rotation of this body set of axis. Okay. To establish one on reference point, we have one reference point. One point is fixed. Point 2 can be only 2 coordinate system constant depth. Okay. Okay. I have written here. 3 of the coordinates are needed to specify the coordinates of the origin of the body set of axis, and the remaining 3 coordinates must then specify the orientation of the primed or body axis. This is body axis. Prime. The dotted axis is your space axis, a parallel axis with space axis. For compare, the space set axis is comparing here. So you can say this is the angle between space and body set of axis. So the 6 generalized coordinates means 3 are the origin coordinates of this origin, and 3 are these 3 angles. Okay, in the next session we see actually these angles are Euler angles, which these 3 angles, how a body set of axis exactly matches with space set of axis if these angles are Euler angles. Okay. Clear? So 6 degree of freedom for 6, that means 6 generalized coordinates are required. Among them 3 are the coordinates of the origin of body set of axis, another 3 are the angle of rotation. Are in doubt? Hello?
No, sir.
No
ठीक
doubt.
है.
Okay. Then it is very important Euler angles. Euler angle, the 3 independent parameters which would completely specify the orientation of a rigid body about a fixed point or about center of mass are 3 angles, and one of the simplest set of such angles are Euler angles. Euler angles is one set of those angles. Okay. Euler angles are 3 successive angle of rotation. 3 successive angle of rotation. Order will be all same. Okay. Phi, theta, psi. We see order. So first you rotate phi, then theta, then psi. Okay. Order successive angle of rotation. You cannot rotate first theta, then phi, then psi. You can Euler angle. Euler angle means the 3 are successive angle of rotation arise due to 3 successive rotation performed in a specific sequence for transforming a given Cartesian coordinate system to another. Means body set of axis to space set of axis, or space set of axis to body. Both are Cartesian coordinate system. So we can get a body set of axis of a rigid body from space set of axis by 3 successive rotation through Euler angles. The Euler angles are 3 successive angles of rotation which is performed in a specific order, so that a space set of axis is give you the body set of axis. Okay. So how it is achieved? Let's for the simplicity, let's assume x, y, z with the orthogonal space set of axis, and unit vector I cap, j cap, k cap, and x prime, y prime, I is a body set of axes whose unit vector are I prime cap, j prime cap, k prime. Okay. Now we carry the transformation from so that x, y, z exactly matches with x prime, y prime, z prime. It is our aim. X, y, z exactly matches with x prime, y prime, z prime. Are you getting my point? Hello?
Yes, sir.
Okay. So fast rotation. A rotation is specific order and that rotation fast. How what is done fast? Then that will be always done fast. Then second, then third. You cannot arbitrarily change that fast. Second rotation you can write fast or third rotation you can write fast. Always you write fast, do fast rotation, then second rotation, then third rotation. Or specifically the angles are given fast phi angle, then theta, then psi. First space set of axis is rotated through angle phi anti-clockwise about the space z axis. Okay, it is the space z axis x, y, z. So we rotate about the z axis. And you know, two property of a rotation is important. One property is axis of rotation remains constant throughout the rotation. You know that rotation we are rotating about this means it is rotating, but this axis of rotation remains constant. So your z axis remains constant. Okay, so only change will be what will change on for x and y axis. So through phi angle rotation means x goes to a new x1, y goes to a new y1. The angle is phi. Okay. The new position of coordinate will be x1, y1, let's say z1, this one. If I1, j1, k1 the unit vector along x1, y, and then the transformation equation can be written as, you already know in transformation equation, actually it is a two-dimensional transformation equation of phi angle of xy plane, just like you know cos phi I cap or sin phi j cap I1 and j1 minus sin phi cos phi a cap. K remains same, k1 is equal to k cap. Or in matrix form, I can write this I1 j1 k1 is equal to cos pi sin pi 0 minus sin pi cos pi 0 0 0 1. Okay. Okay. You know this in two dimension actually cos pi.
Yes, sir.
Okay. So let's take this matrix as a D. The first rotation is rotation about z axis through an angle phi. Then go to second rotation. Second rotation is after first rotation we got x1, y1, z1 and leave this. Now our new axis is x1, y1, z1. Now we rotate x1, y1, z1. For this rotation, let's second rotation is rotate about x1 axis anti-clockwise through an angle theta with the new position x2, y2, z2 so that the z2 axis coincide with the body z prime axis. Okay. So we rotate theta so that this z2 will be z prime around this I. So it will remain constant. Only this change theta and this change theta. Theta is so that this will be your z prime body z axis. Similar like previous case, the matrix will be since it is in rotation in yz. I fix the rotation in yz plane. So cos theta, angle is theta, sin theta minus sin theta, cos theta. You know this. So this is your matrix. Okay. We take it C. Here x1 is equal to x2. This line is known as line of intersection between two planes, xy and new x prime, y prime plane, or known as line of nodes. And third rotation performed about z2 axis. Now we get x2, y2, z2. z2, y2, and x1 is x2, x2. Leave this. So we rotate about this x2, y2, z2 axis through angle psi. So the rotation is performed about z2 axis or z prime axis through an angle psi, so that the new axis x3 axis is coincide x prime and y3 is y prime. So around this we rotate through angle psi. So it will change psi, so that we get the new axis y prime x prime. So here is also xy rotation. So matrix is transformed matrix this. Thus we arrived at finally at a body set of axis x prime, y prime, j prime through three rotations D, C, B. isn't it? So first you perform. So that means you can say if this is total A can be found as it is only one I prime, J prime, K prime is the whole product of three matrix into I, J, K. If you open it, actually how this I prime reached, it will multiply B with I2, J2, K2 reverse way. We result is this one. How it is get? You say by performing this B on I2 X2 I2 Z2 means I2 Z2 K2. But how I2 Z2 K2 is achieved? By performing C on I1 J1 K1. How I1 J1 K1 achieved? By performing D on IJK. Isn't it? Hello?
Yes, sir.
So, and these three, so basically we can say I prime, J prime, K prime is a transform of the A into IJK. Or comparing this, we can say A is equal to B into C into D. Product of three matrices. So, inverse is XYZ can be achieved by A inverse this. So, A matrix you can calculate. If it is action or examination, you have to write up to this. Multiplication of this three, and we got this. And it is actually orthogonal matrix. Orthogonal matrix, a transfer. Okay, so means A inverse is equal to A transpose. For a orthogonal matrix, A transpose is equal to identity 1. That means, but we know that A inverse is 1, so A transpose is inverse. So it is a orthogonal transformation. So if you transpose, you can take the inverse. It is a orthogonal transformation. Okay, orthogonal all are a inverse transpose. So in that way, you can show that if BCD transpose A transpose is equal to A inverse. So if you calculate A transpose means rows and column interchange. Isn't it? Transpose means what? Hello?
Yes, sir.
We change the row to column, column to row. This is all about Euler angle. Then come to the next important point, Euler's theorem on the motion of a rigid body. Euler's theorem tells that the general displacement of a rigid body with one point fixed is a rotation about some axis. If that point is fixed, reference point, then the displacement means only rotation. Okay. The theorem somehow analytical proof. The theorem means that for every such rotation, it is always possible to find an axis through the fixed point oriented a particular polar angle theta and phi, so that a rotation by the particular angle psi about this axis duplicate the general rotation. The three parameters characterize the general rotation. It is possible for Euler angles to produce. Okay. A theorem tells that if one point is fixed, the displacement means rotation. Okay. How we prove? Okay, we use here two things. One thing is axis of rotation remains fixed for rotation, and due to rotation, the magnitude of vector does not change. Suppose one vector is present here in XYZ frame. If we rotate XYZ frame, the look this, then the vector will like this, but the magnitude of in both the cases will be same. Vector magnitude does not change. I cap, J cap, K cap will be different, direction will be different, but if you take final magnitude will be same. If the fixed point is taken as the origin of the body set of axis, then the displacement of rigid body involves no translation of the body axis. The only change is the orientation. The theorem then states the body set of axis at any time d can always be obtained by single rotation of the initial set of axis. In other words, the operation implied in the matrix A describing the physical motion of the rigid body is a rotation. Now, so the theorem means the matrix A, what we see there is represent a rotation. Obviously, it is characteristic of rotation that it is characteristic of rotation that one direction, namely axis of rotation, remains unaffected by the operation, and any vector lying along axis of rotation must have the same component in both initial and final axis. So axis of rotation remains same. So if a vector lies along axis of rotation, it will remain same. It is I cap, J cap, K cap remains same. Okay. The other necessary condition of rotation is that the magnitude of the vectors be unaffected. is automatically provided by the orthogonality condition. Okay. Hence, Euler's theorem will be proven if it can show that there exists a vector R in the same component in both the system. Okay. So this A represents rotation. How we show that? We know rotation means axis of rotation remains fixed. Let R be the axis of rotation. Then when this operation transformation occurs, it will be remain same as R. Okay, so prove slight analytical proof of this theorem. So first assume that the axis of rotation remains same. So if any vector lies on the axis of rotation, it will remain same. Let that vector be R. So when R prime is after operation of A R, when A operator on R, it will be obviously R because it is R is in the axis of rotation. Okay. So this equation can be slightly written as AR into lambda R, where lambda is equal to 1. Isn't it? Hello? This is the starting of the proof. Other thing left those whatever written. Starting point is since it is a rotation means some vector in one vector maybe remains constant. Let that vector is R. Okay? Hello? Are you getting
Yes,
my
sir.
point? Okay.
Yes.
So now we then go to my, but we can write this R means 1 into R is equal to R. So it may be general equation, eigenvalue equation AR, it is operator, AR is equal to lambda R. So which may be constant. The values of lambda for which equation Q is solvable is known as the characteristic equation and the eigenvalue equation. So now our problem reduces to getting the eigenvalue 1. If it will be eigenvalue 1, then it will be R and R prime, so it is a process is a rotation. The problem of finding vector that satisfy 2 is therefore called the eigenvalue problem. Okay. If eigenvalue equation and the vector eigenvector. So Euler theorem can now be restated as the real orthogonal matrix specifying the physical motion of a rigid body with one point fixed always as the eigenvalue plus 1. A eigenvalue plus 1 it will be AR and will be A. Okay, rotation. That means AR minus lambda R is equal to 0 or A minus lambda I into R is equal to 0. The eigenvalue equation. If you expand this, A is a matrix, it has components A11, A12, A13, B11, B1, sorry, A21, A22, A23, A31, A32, A33. A means A11, A12, A13. And lambda into I means identity matrix 1 0 0 0 1 0 0 0 1. It will be A21, A22, A23, A31, A32, A33. Now this will have much. Lambda means only this will be lambda, this will be lambda, this will be lambda in diagonal. Other are 0. So only A11 minus lambda. Okay, if you multiply with the R means X, Y, Z.
Sir,
Ah.
so eigenvalue used to be called as storing all the information of the matrix, so means eigenvalue one of the row one.
No, eigenvalue is not all about the matrix. Eigenvalue actually operation. When we operate on some function, what value it give? Okay, if it is the product of that function and some value, that value is your eigenvalue. Hmm. Hmm. Actually, eigenvalue rule is you can say sum of eigenvalue is the trace of that matrix, and product of eigenvalue is the determinant of that matrix. We can say from eigenvalue concept, we can determine these things. The sum of eigenvalue is the trace of that matrix. Trace means addition of diagonal element, and determinant of this matrix is equal to the product of its eigenvalues. From those two properties, you can determine anything about the matrix, not other things. Okay. So this will be like this. If you expand this, you got these equations. Equation 4 comprises a set of 3 homogeneous simultaneous equations. They can furnish. So physical this corresponds to circumstance only direction of eigenvector can be fixed. The product of constant and eigenvector also is the eigenvector. Okay. Now our aim is to find this. It will be multiplied x, y, z. So a minus lambda I determinant should be 0. Since x, y, z is multiplied this one, it gives you 0, 0, 0. That means this a minus lambda I determinant should be 0. It is a secular equation, you know, in matrix. Characteristics of secular equation. For eigenvalue, a is equal to lambda I means a minus lambda I determinant should be 0. And our aim is to find the value of lambda which must be plus 1. If the one of the root will be plus 1, then we can say a is equal to lambda and it is a orthogonal transformation and this represents rotation. Okay. So now our aim is to prove the root of this equation, one of the root of this equation must be plus 1. So how you can prove from orthogonality property? We know that A inverse is equal to A transpose. So A minus 1 into A transpose. If I take a determinant, it will be a product A into A transpose minus A transpose. Let's okay. But A transpose is equal to 1. So 1 minus A transpose. If we take the determinant of both sides, determinant of A minus 1 into determinant of A transpose, you determinant of 1 A transpose. Okay. But A represents an represents a rotation, or it is an orthogonal matrix. And to describe a proper rotation, determinant of this matrix must be 1. And determinant of a matrix is same as determinant of its transpose. Transpose row is column. Into column. You also see any rotation in 2-dimensional rotation, whatever matrix you write cos theta, sin theta, the determinant is 1. If you 2-dimension, we write this one 2-dimension, or here 3-dimension. What is cos square theta plus sin square theta? Determinant is 1. Determinant is 1. Determinant is 1 because it is orthogonal transformation. Proper orthogonal transformation. Improper means it minus 1. Okay. So determinant, if you calculate determinant of this is equal to this into determinant this, but determinant of A transpose is same as A, which is equal to 1. That means A minus 1 transpose is equal to 1 minus A transpose. But transpose determinant is same. So whether it is 1 minus A transpose is same as 1 minus A. So A minus 1 transpose is equal to 1 minus A transpose. Means A minus 1 transpose is minus of A minus 1 transpose. 1 minus A is minus of A minus 1. Isn't it? That means we found a matrix B is same as determinant of minus B. But we know that from the matrix property, the determinant of minus B is minus 1 to the power n determinant of B. That means here n is equal to 3. So minus 1 minus A determinant is equal to minus 1 by 3 A minus 1 determinant. Minus 1 by 3 minus. So A1 determinant is equal to minus of A1 determinant. Which quantity is negative of same quantity? That means x is equal to minus x. Then what is the value of x?
0.
0. So that is 0, and so that implies that A is equal to 1, or we have one eigenvalue plus 1. This is your Euler's theorem. It proof is somehow analytical. We prove with 3 steps. First step, we prove that it must be rotation. Rotation means axis of rotation fixed, vector along axis of rotation fixed. For that, then we write it in a eigenvalue equation. Lambda must be plus 1. So proving lambda must be plus 1, we have to show this, and finally found in determinant 0, lambda must be plus 1. This is your Euler theorem. Any doubt?
No, sir.
That is a general theorem also.
Sir, could you please represent that Euler's theorem on the motion of rigid body that I want to take this screenshot, sir.
Oh, I will send this material to you. Don't worry.
Sir,
I will send.
I didn't find that one.
No, no, I am sending in your group. Everything I am sharing in your
Okay.
group.
Okay, sir, I will search.
Okay, I will send this slide in your group. But don't worry. Okay,
Okay, sir. Thank you.
I will
Thank you.
send it in your group. Okay. Then comes to the angular momentum and kinetic energy motion about the point of a rigid body, which are written in your syllabus. Okay. So now a rigid body means we assume there is a space set of axis and there is a body set of axis. Body set of axis means there is a origin of body set of lies inside the rigid body. Okay. This one. Now we have to prove this find the kinetic energy. This was nothing else. This one just to prove what the, let's say there are 2 points R1 and R2. This is the position vector of first point 1, position vector of second point 2. Okay, R1 this R2. So by definition R1 direction this, R2 this from this point. We already in central force problem discuss this. Let's say direction of R is this. So according to vector algebra, here direction you are to R1 plus R is equal to R2. Enough it?
Yes, sir.
Then let's say first assume that if the origin of the second set of axis is considered a point defined related to first, uh, then the derivative R2 related to x. So dr by 2 by dt. If R2 is equal to R1 plus R, if I take its derivative, then dr2 by dt will be dr1 by dt plus dr by dt, which is equal to dr1 by dt plus this one. This is equal to omega plus r because dr by dts is equal to omega r, and that derivative r related to zero must vanish. We have a relation. If a space set of axis and body set of axis relation, which actually I have not written here, that relation is for space set of axis outside, which was dr by dt space is equal to dr by dt rotation plus omega 1 plus r. Any vector. Actually, it is in a Coriolis effect what we had during cyclone or anything Coriolis effect. But not in the syllabus, I have not written here. Actually, variation of any vector d by dt of any vector, let's say in space coordinate, space means outside this one. This is your space is equal to, if body is rotating with angular velocity omega, then this equal to dg by dt rotation plus omega cross g. For any vector, g is r, then all g will be r, k all, k a all a. This is the general formula. A space and rotating r or body set of space set are related by this equation. Okay. This equation, space set of this is a general equation. Okay. So, but dr by dt in rotation is r is a fixed vector in the body set of axis because r is a fixed distance between any 2 points in rigid body is fixed. You know that means r is fixed. Distance between any 2 points in rigid body fixed means r is a fixed vector in body set of axis. So dr by dt will be how much?
0.
0. Okay. So dr by dt is equal to 0. So this term is 0. So we only found the omega 1 plus r. So that means dr2 by dt, dr1 by dt plus omega 1 plus r. You have to remember. Okay, this will be omega 1 plus r. Other things. But here we prove that omega 1 and omega 2 is same. That means the body is rotated with a constant angular velocity. Whatever be the point, if you take this is the reference point, this is the reference point, this is the reference point, we assume body is rotating with same angular velocity omega, independent of reference point. That proof is not okay. Then exactly come what is in syllabus angular momentum and kinetic energy. Omega 1 momentum and say same angular velocity. We know that angular moment, how you, L angular momentum is equal to r cross p. P is the linear momentum. Angular momentum is equal to r cross p. You know it?
Yes, sir.
But p is equal to mv, mass into velocity. mv. So
Yes, sir.
L is equal to r cross mv. If it contains large number of particles, we call sum over I, ri, mi cross mi vi. Okay. Mi is scalar, I can take outside. Sum over I, mi, ri cross vi. This is the angular momentum expression. Okay. Ri vi is the radius vector and the velocity respect to the ith particle. That is the given point. Since ri is a fixed vector, if it is in the rigid body means the distance between two point fixed, it is in a rigid body. Ri is the position vector with respect to this one point, then it will be fixed. So dri by dt is equal to 0 in rotating space. So dri by dts is equal to dri by dtr plus omega cross r. And dri by dt is equal to 0, then we call dri by dt is equal to omega cross ri. And dri dt in space means the normal velocity. Space coordinate what we assume, so vi is equal to omega cross ri. For rigid body we get this equation. Okay. Otherwise you get v across omega, but here you remember v is equal to vi is equal to omega cross ri. It comes from this analysis. Space is equal to rotating omega, but rigid body distance fixed. So the r means rigid body, inside the rigid body is 0. Space is outside.
Sir, it is written when a rigid body moves with one point stationary. That one point should be point center of mass or any other.
If it is not given the center of mass, if it is some problem given this point is reference point, you take the reference point.
But
One
then also this will be applicable. This.
This is
equation.
applicable.
Okay.
For rigid body, this is the equation what right? dr by ds is equal to dr by dtr plus omega 1 r. It is for all. This expression, this is for all rotating body. If it is body or rigid body, then distance between 2 points is fixed. R is fixed, so this will be 0.
And sir, translational motion is not considered here. Only rotational body is considered.
Yes, only we are considering rotation.
Okay.
So V is equal to omega cross Ri, but you know V is equal to R cross omega. But here slight different, omega cross Ri. If you forget this, then you can't get the result. Okay, V is equal to omega cross Ri. Here,
yes, sir. Thank you, sir.
So now angular momentum L is equal to, we put M R cross Ri cross V in place of Vi, you write omega cross Ri. Okay, then take the vector identity A cross B cross C is equal to B A dot C minus C A dot B. You already know that. So if you substitute this in place of omega cross Ri, Ri dot Ri is Ri square, same vector dot product, and Ri omega is equal to Xi omega X plus Yi omega Z omega, R is equal to X Y Z. Okay. So finally we found from this equation L is equal to this. So what L means Lx I cap plus Ly j cap plus Lz k cap. What is multiplied to I cap, that is component is Lx. What is multiplied to j cap, that is Ly, and what is multiplied to k cap, that is Lz. So comparing this, you can say Lx is equal to how much? Here vector is here in place of omega x. Omega is you put omega x, y, omega j, omega cap. In Ri you put xi cap, y cap, j cap. So with I cap, what is multiplied? If you see here, omega x Ri square and mi. So omega x Ri square from this equation minus with I cap. I cap means omega x square xi. Omega x here. Omega xi, sorry. Ri. Omega x xi, Ri means what? Xi, y I cap, y j cap, z cap. So I cap means it will multiply with xi. So this term multiplied with xi. Xi square omega x, xi yi omega y, xi zi omega z. That will minus xi square omega x, xi yi zi. Okay, can you get equation 4 from 3? Please see. Here component Lx means which was multiplied with I cap. Open this with I cap means a constant is multiplied with this omega. So obviously the I cap component is omega x ri square. No problem here. And into mi is multiply everything. Hello?
Yes, sir.
Similarly here, all these three terms are multiplied with this. I cap means it is multiplied with xi. So I only write xi into this. Here I written this. Okay. Similarly, you found your Ly, Lz, same component, and finally you got you see it is something multiplied x, omega y, omega z. So we can say it is I xx into omega x is constant. I y xy into omega y, I xz into omega z. Similarly, Lz, Yz can be written, or finally you can write Al is equal to and Ixx is what? Which is multiplied by x component. This is equal to mi ri square minus xi square. Ri square is xi square plus yi square plus z square. R square. R is a vector xi cap plus y cap plus z cap. Then what is a ri square? Xi square plus y dot xi square plus y square plus z square. Is not it?
Yes, sir.
So the bracketed term will be how much? Xi square plus yi square plus
R
zi
square.
square, zi
R
square
square.
minus xi square. So xi square cancel, only y square
Y
plus
square plus Z square.
that's the problem. Okay. So the ri square x square we can let y square z square. You can here written this is nothing but mi into y square plus zi square. But the product term, suppose this one ixy is equal to how much? xi yi mi xi yi minus mi xi yi ixz minus mi xz. So what written xi zi xz xi yi xi or minus sign. Okay. So product term will be ixy means minus mi xi yi for all things. If yz or minus mi yi zi. If combine these two, you can write one form. You can combine these two. If x is equal to y is same, both are same, then we found mi yi square plus zi square. If both are different, then it will be minus xi yi. Combining these two, I can write like this. I can write like this. Ixx is equal to sorry. It is in a continuous. It is discrete. It is continuous. Then I combine in continuous form. It will be continuous means points are all continuous. Then instead of summation, I use integration. You know that. And variable density and rho dV. Volume is equal to rho into dV. You know it. In
Yes, sir.
electrostatic, you know,
Yes, sir.
charge Q. But when you do continuous body, you know charge density rho into dV. You know everywhere. So rho dV into this quantity r square minus x square. Ixx. Oh. Rho contain already mass. Rho is mass per volume. So mass is absorbed by rho. Volume dV and rho r square. Similarly, this one is value rho r xy dx dy. Okay. Combining these two, I can write this equation ijk is equal to this. If j is equal to k, then delta jk is equal to 1 and is equal to r square minus x into x square. If I is not equal to j, then this j is not equal to k, this is 0, only minus xj xk. Are you getting my point? Combine these two. This one is the first. For second, actually, if I write ixy, it will be what? Volume V minus sign minus okay rho xy
My
xy dv and second term this one in integration from okay continuous body. For continuous body rho v on all terms will remain rho contains mi so xy dv. Now combine these two. Combine these two, I can write it like this. This is, for this x is not equal to y. But here x is equal to y. Is the difference or not? Isn't it? Here x is equal to y.
Yes, sir.
When x is equal to y, then there is an extra r square term. But x is equal to y means this one x square. X is equal to x square through extra r square term. So I add r square and delta jk. Delta jk, because we know that delta jk meaning is when x is equal to y, it is 1, otherwise 0. So when x is equal to y, it comes, the extra term comes. When x is not equal to y, it is 0. Clear? Hello?
Yes, sir. Clear.
Okay. Okay. So L is equal to I omega. What I write? L, we know L is equal to I omega. I is a moment of inertia tensor. And then come to kinetic energy term. We know kinetic energy is equal to sum of half mi vi square, half over mi vi dot vi. But one vi is equal to omega cross ri. Keep one vi and in place of other vi, I write omega cross ri. Kinetic. Okay, to simplify this, because kinetic is half mv square means mi vi dot vi square, vi which is vi square. In one vi place I write omega cross ri. Then use the vector identity, because it is a form a dot b cross c which is equal to b dot c cross a which is equal to c dot a cross b. Okay, so I use the b dot c cross a. B is omega dot r cross b. Oh, so that omega I can take. There is no I substitute in omega. I can take it outside. Half omega dot this. But this quantity is your what? Hello? This quantity is Ri, MV is P, Pi. Ri cross Pi is your
Angular momentum.
angular no L. So kinetic energy is nothing but half omega dot L. But L is equal to I omega we got from last section. So you can put it equal to I omega. So kinetic energy omega dot I dot omega. Unit vector omega n cap r cross n. Okay. So we can write also I is equal to mi r cross n square, or you can relate I is equal to, if you got the form 2t by omega square. Right, kinetic energy and angular momentum we already calculated. We go to next session. Next session is moment of inertia. We know moment of inertia from a body mr square. Actually, moment of inertia about an axis A is mi ri cross n came perpendicular distance from that point. Suppose the body is rotating here about some axis, then moment of inertia is the mass into r square. R square is this distance. If we body here, we cannot reach the perpendicular distance. So perpendicular distance can be the unit vector is n cap. It is written as r. So it is written as r ri cross n cap square. This is the perpendicular distance. We know that I is equal to mr square. You know it. This r is actually perpendicular distance with the body and axis of rotation. For perpendicular, I write ri cross n. See, for example, this one. If you take example, here at the origin of axis, n cap is axis of rotation. Body is here, center of mass of body is here moving. Let's say coordinate is r, and here point the coordinate is ri. Then from this relation we have r plus ri prime is equal to ri. Ri means r plus ri prime. Okay. So perpendicular distance from this point, this is the point moving. This distance, this is equal to nothing but ri cross n cap square. Ri cross n cap square. But ri is equal to ri prime plus r if you write in terms of this. So and open this ri prime cross r, ri n cap plus r cross n cap square. We got this relation. Okay, don't know this relation. Mi square m is the body. Actually, there is a close to derivation. We find this. So m is the total mass of the body. If B is the axis passing to the center of mass and parallel to A, then IA be expressed in terms of the momentum about the parallel axis B. It is parallel axis theorem. What you know in your class 2, parallel axis theorem, also you know in class 3, parallel perpendicular axis of theorem. Okay, this is the parallel axis theorem. Means if A and B are to parallel axis and a body is moving about one axis B, we know the moment of inertia about A, then we can know difference is IA is equal to IB plus mass into perpendicular distance square. Isn't it? You know it in plus 1 plus 3
Yes.
parallel.
Yes, sir.
IA is equal to this is the derivation, leave it. This is important. IA is equal to IB plus M arc. Here only distance means to it is in mind perpendicular distance. Huh? So in place of R we have always write R cross N. More. And then leave this on. This is a problem, very important problem. Generally comes in our examination. Calculate the elements of the moment of inertia tensor for a homogeneous cube of mass m, density rho, and side A, assuming that the axis lies along the edges of the origin. And this is a cube. Find the moment of inertia. That's on the figure. Cube means every side is same A. So how you calculate the moment of inertia? We use that formula Ijk as integration of V rho r square delta jk minus xjk dv. Here r square is equal to x square plus y square z square. Or you can take x1 square plus y1 square z square. So what is the Ixx component? According to this formula, when x jk is equal to same, x's component is equal to r square minus x square, which is equal to y square plus z square. And since a cube and volume integral means volume over length, breadth, and height 0 to a 0 to a 0 to a. Are you getting this point? Hello? This is very important question. Calculate the moment of inertia. We know the moment of inertia formula. Only here given it is a cube. So volume element means dx, dy, dz. X varies from 0 to a, y varies from 0 to b, and z varies from 0 to a. dv means what? dx, dy, dz, and integration varies from 0 to a. And this expression, if both are same, then it will be delta 1. So r square minus x square, which is equal to r square is equal to x square plus y square plus z square minus x square. X square cancel, the y square plus z square. Okay?
Yes, sir.
Alright,
Yes, sir. Understood.
then you get the integration. Integration is very easy. In first you take integration with respect to, there is no x, so you separate the x. Y z integration. Let's first do integration with respect to z, dz. The dz if you integration, it will be z cube by 3 and okay. Oh, first integrate to y, then we integrate. Y means y cube by 3, z square y. Put value 0 to a, so it will be a cube by 3, it will be a z square. Integrate z, it will again z cube by 3, a q z. Put value and a 2 by 3, a 5. So we found Ixx is equal to 2 by 3. In place of rho mass per volume, I can write m by aq 2 by 3 m a square. Similarly, calculate the off diagonal element or Ixx. Similar xx, yy, zz all are same. 2 by 3 m square is symmetric tensor. Symmetric tensor means diagonal elements. Okay. Off diagonal is also Ixy is equal to Iyx. So Ixy calculate according to this formula. According to this formula, if x is not equal to y, this term is 0. So only minus xy. Okay. So minus xy. Integrate dx dy dz. We found this. So similarly, so the total matrix will all of diagonal elements have same value. Symmetric matrix. This will be the resultant matrix. Okay. Okay. Can you derive this or not? This is very important question. In general, comes find this moment of inertia. Then Euler equation of motion. Uh, that was your Euler angle, Pythagoras, then Euler theorem that we tell that it is a rotation. If one point is fixed, then the general displacement is rotation. Then Euler equation of motion. Third one, for the rotation motion about a fixed point at the center of mass, the direct Newtonian approach leads to a set of equations known as Euler equation of motion. You can say it is the equation of motion for a rigid body. We consider either an inertial frame whose origin at the fixed point of the rigid body or a system of space axis with origin at the center of mass. We have two possibilities. Whether you take it as a center of mass, origin is the center of mass, or any point, inertial frame, origin is a fixed point. In the two, if a rigid body is rotating under the action of a torque, rigid body rotating means a torque is acting on it. Torque will be dl by dt. Dl is angular momentum, you know that. But according to formula, we know that for any vector, d by dt of that vector in space coordinate is equal to d by dt of that vector in body coordinate plus omega across that vector. Okay, the general relation. But this is your n dl by dt, so I can write like this. So n is equal to dl by dt body plus omega across that. Okay, since only one substitute, you can remove the substitute and write dl by dt plus omega cross L is equal to n. Okay. But L is equal to I omega, I1 omega 1 I cap plus I2 omega 2 j cap plus I3 omega 3 k cap, omega is omega 1 I cap, omega 2 j cap, omega 3 k cap. Okay, so dl by dt is how much? So dl by dt is equal to I1, I2, I3 are constant, so I1 d omega 1 by dt means omega 1 dot plus I2 d omega 2 by dt means omega 2 dot plus I3 d omega 3 by dt means omega 3 dot k cap. Okay. So n is equal to how much? Final n will be dl by dt plus omega cross L dl by dt plus omega cross L means cross product, you know, calculated through determinant like this. Isn't it? Hello?
Yes, sir. Yes, sir.
Then calculate the determinant. This determinant is I cap into omega 2 I3 omega 3 minus omega 3 I2 omega 2. Plus j cap means I have to add minus. Plus j cap is equal to omega 3 I1 omega 1 minus omega 3 I3 omega 3 plus k cap omega 1 I2 omega 2 minus omega 2 I1 omega 1. Okay. But n is equal to n1 I cap plus n2 j cap plus n3 k cap. Now all I cap you collect at one point, j cap and k cap similarly. So this thing is I cap. I cap means this one, this one. Okay. So j cap this one, this one. So k cap this one, this one. So n1 I cap plus n2 j cap plus n3 k cap is equal to this. Finally got, because I1 omega dot plus omega 2 omega 3 taking common, it will be I3 minus I2. Here omega 3 omega taking common, I1 minus I3. Here omega 2 omega 3 taking common, it will be I2 minus I1. So comparing the coefficients, I cap, which I cap multiplied n1 must be equal to this quantity, n2 must be equal to this quantity, n3 must be equal to this quantity. I written like this. Okay? Are you getting this point?
Yes,
Only
sir.
comparing. This is actually your Euler equation motion of a rigid body. Very easy and simple. Euler equation of motion. Combining these three, we can write this is Ni. I may want to do I d omega I by dt plus this term epsilon I j k omega j omega k I k. The Levis beta symbol you know in mathematical physics. This meaning is if I, J, K are in the same order, it will be 1.
That's
Cyclic
one.
order.
If
If I,
order will change, it will be -1.
if, and if repeated, then it will be 0. If I is equal to J2, I, K is 0. So this is the formula. This is your Euler's equation of motion for a rigid body.
Sir, this is in which unit in our syllabus?
Your last rigid body, all are what I have done discussing today, all are from your rigid body. Last unit, I think, that are rigid body. And sometimes next one is your heavy symmetrical top. What is your syllabus? This is symmetric body. Symmetric body means two moment of inertia are same. It is symmetric about one axis. Generally, rigid body where symmetric I1 is equal to I3 and is not equal to I2. Is symmetric about I1 is equal to I2. If I1 is equal to I2, then this term becomes 0. Okay, and it becomes simpler about the axis. We discussed that is your symmetric top, heavy symmetrical top. Next thing is heavy symmetrical top. Symmetric top slide is visible.
Yes, sir.
Uh, the last part is heavy symmetrical top. Actually, one example is your top, child top, which is not two. This is an example.
Please mute yourself.
Please, all participants are requested to mute yourself. Someone or someone.
Only host
Jahan,
can
please
mute.
mute yourself. Israt Jahan, please mute yourself.
इशरत जहाँ
Okay. So heavy symmetrical top is the last part with one point fix. This is the like a rigid body. Consider the motion of a symmetrical top in a uniform gravitational field with one point on the symmetry axis is fixed in space. A wide variety of physical systems ranging from a child's top to a complicated gyroscopic navigational instruments are approximated by such a heavy symmetrical top. Both for its practical application and the illustration of many of the techniques previously developed, the motion of heavy symmetrical top deserves a detailed exposition. The symmetry axis is of course one of the principal axes. Among I1 or I2 or I3, one is symmetry axis and will be chosen as the Z axis of the coordinate system of the body. Okay, third Z axis. So symmetry axis Z. That means about this Z axis symmetry. Expert Y part. Since one point is stationary, the configuration of the top is completely specified by three Euler angle. Symmetric top with one point fix. One point fix means we only angles are needed. Theta give the inclination of Z axis from vertical, phi measures the azimuth of the top, and psi the rotation angle. You know phi theta psi, what is written? Okay. Okay. This angle is theta. Compare Euler angle. Huh? First is phi, then psi. Okay?
Okay, sir.
Okay. This is the figure of the rigid body. The rate of change of these three angles give the characteristic motion of the top. Psi dot we call rotation d psi by dt, rotation of the top about its own figure axis z. Psi dot. It is own figure axis z axis, rotation about z axis. We know. Then phi dot precession or rotation of the figure axis about vertical. Phi dot rotation which is called precession about the vertical, and theta dot nutation bobbing up down of the figure axis. Okay, up down when you see top is moving, it is moving like bobbing up down moving. That is a phi dot. And precession means suppose it is the axis, it is moving like this around it, precessing. Rotating about yourself, that is rotation. That body is itself rotating. But you see, for top case, suppose this is your body, and it is rotating itself, and it is also rotating about the axis. That is called precession. In inclining rotation, precession, and also that bob is up downing. That is your called nutation. Okay.
Sir, up down is called
Nutation. Bobbing up
new.
down.
Okay.
Nutation.
Sir, what is bobbing?
Bobbing up down means just moving up down. Its point, final point is not rest. The pin point. It will just moving up down, slightly changing position.
Okay, sir.
Uh, okay, for many cases, actually, the condition for psi dot is much greater than theta dot is much greater than phi dot. Symmetrical top means here we take I1 is equal to I2 and is not equal to I3. Putting I1 is equal to I2 in that equation, we got this I1 omega dot plus this I3 omega 3 dot. Isn't it? Uh, so Euler equation may not provide most useful rescue motion of symmetric top. So we use Lagrange's procedure to obtaining this equation of motion. So here we use Lagrange's procedure. That is Lagrange T minus B. Calculate T minus B and proceed. The kinetic energy of heavy symmetrical top T is equal to how much? We know kinetic half I1 omega square plus I2 omega 2 square plus I3 omega 3 square, but I1 is equal to I2. So I write like this. And this velocity vector omega 1, omega 2, omega 3, these are, you have to remember this. There is a derivation here, but difficult to write. If you want, I can provide the derivation, but you have to remember this omega 1. If you do this long question, you have to remember this omega 1, omega 2, omega 3. After putting this and squaring, we found the square and addition. We got this one. Kinetic energy is this. Similarly, potential energy, it is in a gravitational field. So potential energy, what is, you know, mgh. Okay, h is ri g, m ri g, g the constant vector of oscillation due to gravity. Summed over mi ri. If we consider total, m is the mass of the body, r is the position vector center of mass, then we can write m r dot g. R dot g means gl cos theta. In figure, this is L. So that is GL MGL cos GL cos theta. So Lagrangian will T minus B, kinetic energy minus MGL cos theta. So here you see which one is cyclic coordinate. Please look at the Lagrangian. Cyclic mean does not appear in the Lagrangian. Among theta, phi, psi, which one is cyclic coordinate?
Psi is the cyclic coordinate.
And what about phi?
Yes, sir. Phi also.
So if they are cyclic means what it implies? Its corresponding momentum is constant. So p psi and p phi are constant of motion. So p psi is equal to formula del L by del psi dot. You calculate this. This is a I3 and this one is omega 3 quantity is a constant of motion, and p phi del L by del phi dot is also a constant of motion. I can write p phi is equal to constant I1b. Okay. So now the total energy T plus B can be written as T is this and V mgl cos theta. Only 3 additional quadrats are needed to solve this problem, and they easily obtained from the 3 first integral without any Lagrange equation. Here Lagrange's equation d by dt del by del q dot minus del by del q0 cannot give the height to the equations, but from using the knowledge of energy and E and Lagrangian, we can using the quadrature formula we can derive the solutions. Okay. From equation 5, this one p psi is equal to I1a. We got this I3 psi dot is this, and substituting it in equation 6, this one p pi, we get this plus this is equal to I1a. From these two, we found phi dot is equal to b minus a cos theta by sin square theta. Already written, trigonometric simplification. The theta were known as a function of time. Equation 9 could be integrated to furnish the dependence of phi on time. If we integrate theta, you know the variation of theta on time, then we can also phi on time. So I3 psi dot is equal to I1a minus I3 phi dot cos theta. 9 back in equation 8. Written here already. I3 psi dot is equal to I1a minus I3 phi dot cos theta. Now put in place of phi dot its value, b minus a cos theta by sin square theta. So we got psi dot is this. This above equation is funny. It is only psi in a function of theta. And that equation is phi in function of theta. You know the variation of theta with t, then you can calculate phi dot and psi dot. And from energy equation resulting the differential equation of theta. From equation 5 we have omega 3 I1 I3 constant time, thus E is a constant of time. Also, then you simplify E using phi dot psi dot value. Nothing else. You have details are given here, details mathematics is given here. Finally, we found the energy E prime is equal to this in terms of constant B, A, other things. So, but E is equal to actually kinetic energy plus potential energy. So, you can calculate, all calculations are given here, details are given here. You can calculate like this. Okay. All mathematical calculations are given in the slide. I am
Okay,
not
sir.
repeating that. I am not repeating. Only addition trigonometry. So actually, energy is equal to T plus B. But T for rotation, you know, I theta dot square is kinetic energy, half I theta dot square. So the rest one is your effective, just like V prime, right like that. So E prime is equal to kinetic T plus V prime. Okay. Thus we have four constant associated with the motion, the two angular momentum, P psi V phi, and the E I3 omega square potential energy term MGL. And these are the constants. MGL is a constant, energy minus this is a constant. We also use other constant alpha, beta, A, V in terms of the constants. You can write E is equal to this one. You want to return of energy E. This equation. I1 B this equation MGL cos theta. If we use this quantities, so I found this. Now okay. Equation 11. 11 this is your equation which is written here. E prime is this or E is equal to this. I can write this equation 11 is same. I1 theta dot whatever written. Now multiplying 2 by I1 in each term. Multiplying 2 by I1. Here 2E minus I3 square I1 theta dot square is I1 2 by I1 in every term. We got this. Plus 2 half cancel or I1 cancel theta dot square. Here 2 half cancel, I1 cancel, this one. Here 2 and I1 remain. Okay. So or from this equation I can say alpha is equal to theta dot square. This quantity is your alpha. See? Alpha. This quantity b minus a by sin square theta square by sin square theta, it remains same, and the mgl is your beta 2 mgl by I1. 2 mgl by I1 is your beta, so I like beta cos theta. So it is alpha is equal to theta dot square plus b minus a cos theta square beta cos theta. Okay, you see all method done here. So if you from this equation we can let's multiply sin square theta in each term. If you multiply sin square theta or it will be alpha sin square theta, theta dot square sin square theta, and it can b minus a cos square theta, beta cos theta sin square theta. That is sin square theta, theta dot square is equal to sin square theta, taking common alpha minus beta cos theta and b minus a cos theta all square. Using variable, let's put u is equal to cos theta. If you put u is equal to cos theta, then what is u dot or du by dt is equal to how much? U is equal to cos theta. What is du by dt?
Minus sin theta d theta.
Dt, yes, dt. So it is minus sin theta d theta by dt. Chain rule. Del u
Yes,
by
sir.
del theta into the d theta by dt. But d theta by dt is theta dot. So minus sin theta, theta dot. So u dot is equal to minus. So now putting here all in terms of u dot is equal to minus sin theta, theta dot. So it will be minus sin theta theta dot whole square. So it is u dot square. And this term sin square theta. Sin square theta is 1 minus cos square theta, 1 minus u square. It is alpha minus beta cos theta means alpha minus beta u. B minus equals b minus a u whole square. Which can be reduced immediately to a quadrature. So u dot is equal to this. Du by dt is root over of this. And
Sir, quadrature means, sir?
its solution are actually sine trigonometric functions. Quadrature, its solution if you get trigonometric complete functions under some conditions. Not normal things. Normal.
Okay, sir.
Solutions are trigonometric or elliptic functions. Trigonometric also elliptic. U dot is equal to this. So du by dt. This and dt is equal to how much? Du by this. So t is equal to integration of this quantity. Okay. With the above resultant equation 910, 5 can also be reduced to quadrature. However, the polynomial in the radical is cubed, so that we have to deal with elliptic integrals. These solutions can be generated, okay, by computers. A solution is not exactly by using computer, different softwares you can solve this. Or the general nature of motion can be discovered. But we here after that we discuss general motion. We are unable to get a general solution through this mathematics. We have to use computer solve it. Okay. The energy conservation equation is symmetrical top can be written as this is our equation. We got this one. So from that we have found. Let's see. This is our equation u dot square. This. Let's see this term. The convent to design the right hand side of above equation if we are discuss the behavior of cubic function. We consider this to study the function. If you multiply this, you see u square is multiply u here. So that what is this multiplication give you? Okay.
Cubic equation, sir.
If you first use the multiplication, left right. 1 into alpha, first is alpha. 1 into minus beta u is equal to beta u. Minus u square into alpha minus alpha u square. Minus minus plus beta u cube. Then minus b minus au whole square. It will be how much?
Minus b square.
Minus b square plus a square u square minus 2abu. Written bracket, so it will be minus plus. So finally you got this. Now highest on beta u cube, and u square multiplied minus alpha here, minus a square here, minus taking upon alpha plus a square u square, and u minus beta multiplied here, minus minus plus 2ab multiplied here, 2ab by beta u, and constant are alpha minus b square. Okay. Hello?
Yes, sir.
And for a gyroscope, actually the center of mass is a fixed point. So since center of mass fixed, then the constants can be set 0. Okay. For gyroscope, F is only quadratic equation since beta is become 0 because beta is equal to 2 mgl by I1. Mgl is distance from center of mass to ground. If it is fixed point, if the fixed point is center of mass, then it will be 0. On gyroscope, it is 0. F will become more simpler. If beta put 0, then it becomes a quadratic equation. If beta 0, so its solution is very easily you can get the solution. But to understand the general motion, here we have to assume beta greater than 0. Okay. For general motion, beta is greater than 0. And for taking beta greater than 0, we have solve it. The roots of the cubic polynomial furnish the angle. For beta greater than 0, it is a cubic equation. No? The root of the cubic polynomial furnish the angle of theta dot changes sign, that is turning angle in theta. But theta dot changes sign, if you change the theta dot value, theta dot changes sign. theta dot alpha equal this. There are three roots. Cubic equation, the three roots and three possible combination of solution. There can be one real root and a complex conjugate pair of roots. There can be three real roots. Three roots means there are three possibilities. All are may be real. One real or two are a complex conjugate, but two of which are the same, and there are three real unequal roots. This possibility depend upon the relative sign of the magnitude of the four constant in equation 2. Those four constant, it depends on the all value of this four constant. What kind of root will be found? Uh, and there is also the physical constraint that the solution u must satisfy -1 to +1, because u is equal to what? U is equal to a cos theta. What is the maximum and minimum value of cos theta?
Yes, -1 to +1.
-1 to +1. Isn't it? So what is the maximum and minimum value of u? Since u, I can write like this: u is equal to cos theta. So, isn't it?
Yes, sir.
-1 to +1. We'll draw all the figures if u greater than 0, which would case of the if the top is supported by a horizontal surface. Recall the point support could allow smallest root. For u large, the dominant term in fu is beta u cube. Here, see, if u will be large, beta u cube, beta is a positive term. So it is a large quantity. U increases means u cube is larger. Oh, it is a positive plus beta u cube is larger, is a positive quantity. Since beta is always positive constant, fu is positive for large positive u and negative for large negative u. If u is positive, then beta u cube positive. If u is negative, beta u cube is negative for large u. Okay. At point u is equal to ±1. If u is equal to ±1, fu becomes equal to -b minus 0. If u is equal to ±1, if u is equal to +1, it will be beta. A beta minus beta, beta cancel out. +1 is alpha plus a square. Minus alpha plus alpha cancel out. It will be a square plus 2ab minus a square plus 2ab minus b square. That means minus taking common, a square plus b square minus 2ab. Okay, or -1 and plus 2ab. So it is basically minus b minus a whole square. If u is equal to ±1, fu becomes minus b plus minus a square, and therefore always negative. Minus means square is always positive, so minus of a square is always negative, except for the another case where u is plus minus the root. We said this u is a plus minus the root, and at least one root must lie in the region of u greater than 1. Okay, so u plus minus 1, it is negative. U plus 1, it is negative, but large u is positive. Large u is positive, negative. Suppose we see there is a positive value large u or negative -1. What it implies? There must be a crossing over. There must be a root. Or root means x u is 0. U0 must lie in it. So one root must lie u greater than 0. Or u greater than 1. Hence, at least one root must lie in the region u greater than 1. From analysis, we found and for large u is positive. For large u, but for 1, it will be negative. That means it cross at a point and for u greater than 1, and this is gives you root. Okay? Hello? Hello?
Yes, sir.
Okay. So here
Yes, sir. Okay, sir.
negative means must be 0 inside it. How it goes from negative to positive? The root no, hence at least one root lies in a region that does not correspond to real angles. But real angles is u is between -1 to +1, so it is not real case. In a physical motion, the top can occur only when fu is positive, somewhere in the interval -1 to +1. And theta varies from u is cos 0 to pi. Therefore, we will conclude that actual top if you will have two roots u1 and u2 between -1 and +1. The third root is here. So in the cubic equation, the two root must lie between -1 to +1. And the top so that cos theta always remain between the two roots. The location of these roots and the behavior of hydroid theta between them provide much qualitative information about the motion of the top. It is customary to observe the motion of the top by tracing the curve of the intersection of the figure axis and a sphere of unit radius about the fixed point. The polar coordinates of point or locus are identical. They are given. So since b minus AU, you can take u prime equal b by a. I written all these things. One is precession, high increase equivalent one called precession, and one is nutation, nutates. Theta one, p motion. It's the one just picture, precession and nutation. Okay. Then this is all about your symmetrical top. And you read this, what are the implications, but when it is a long question comes, then you have to derive this, do the mathematical calculation, then discuss its significance. Okay.
Okay.
Any doubt? Hello?
No, sir.
Actually, what syllabus was given that time, I don't see that rigid body was not written.
Sir,
Well,
I just saw now only that paper 4 it is there, block 4. Rigid body is there.
I was
And
not.
they have not provided in book also, sir. They have given only lectures of video lectures of different NPTEL courses.
Yeah, yeah. So any doubt?
No, sir.
Okay. So I'll send this material. Okay. If not, then my course is completed here. Okay. I'm sharing this material to you. No problem. Anything else?
No, sir. Thank you, sir.
Okay, thank you. So, okay. So, may I leave now?
Sir, this derivation which you
Ah.
have done in the PDF, that is sufficient or we have to learn from...
Yes, everything is written there.
Okay, sir. Thank you.
Okay. So, I am leaving.
Okay, sir. Thank you, sir.
Thank you, sir.
Sir, thank you.
And please share the PowerPoint.
Thank you, sir.
Yes, sir.
Particular. Thankful to Indran and Banerjee sir who actually informed me regarding the course. Thank you, Banerjee sir.
I am your
Because,
servant, sir. Let us do a good
okay,
job,
okay,
sir.
thank,
Thank you, Lord.
thank you, sir.
हेलो सर हेलो
हाँ 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 संदीप
सर
बोलिए।
सर क्लास का लिंक मुझे सेंड नहीं हुआ था
लिंक में तो ये सिंगल लिंक है वो एक ही लिंक में सब क्लास हो रहा है। ओके।
सर मुझे थोड़ा सा व्हाट्सएप ग्रुप में अगर ऐड कर देते तो अच्छा होता
तो तुम्हारे फ्रेंड लोग को बोले वो ही व्हाट्सएप क्रिएट किए हैं।
Sandeep, you just write your
मेरा कोई
phone number
फ्रेंड
in
अभी
this
तक नहीं
message box. Sandeep, you write your phone number in message box.
ओके सर ओके सर
Okay. Okay, I am leaving. Thank you all.
सर फोन नंबर लिख दिया सर
Hello? Hello? Excuse me? Hello? 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 ये कौन कौन साउंड है?
हेलो
हाँ हेलो
हाँ
हेलो ग्रुप रे आड
हाँ
ହେଇଛନ୍ତି
हेलो
କି
हाँ
ମତେ ଟିକେ ଗ୍ରୁପ ରେ ଆଡ କରିବେନି ଆପଣଙ୍କ ନମ୍ବର ଟା ଟିକେ ଦେବେନି
ମୁଁ ତ ହେଇଛି ମତେ ଆଉ ଜଣେ କିଏ କରିଛନ୍ତି କିଏ କହିଲେ ବୋଧେ ବିଶ୍ଵ କି କଣ ତାଙ୍କ ନାଁ ବୋଧେ କି ସୁଭାଶିଷ ନା କଣ
ହଉ ମତେ ଟିକେ ନମ୍ବର ଟା ଦିଅନ୍ତୁ ନା
ମୁଁ ଦେଖେ କିଏ ଆଡମିନ୍ କିଏ ଅଛନ୍ତି ତାଙ୍କ ନମ୍ବର ଟା ପଠେଇବି ଆଉ
ଠିକ ଅଛି ମତେ ଏବେ
ମୋ
ଟିକେ
ନମ୍ବର ଟା ବି ଟିକେ
ଆପଣଙ୍କ
ଦେବେ।
ନମ୍ବର ଟା ହଁ ନମ୍ବର ଟା ଟିକେ ଦେଲେ ମୁଁ
ମ୍ୟାଡାମ
ଦେଖିବି ଆଡମିନ୍ କିଏ ଅଛନ୍ତି ନମ୍ବର ଟା
7847
ଟିକେ
ଲେଖନ୍ତୁ ମୋ ନମ୍ବର ଟା ଲେଖନ୍ତୁ
ଟିକେ 78
47
7847
ହଁ
07
07 57
57
08
08 7847
7847 07 5708
ହଁ ମୁଁ ଦେଖୁଛି କିଏ ଅଛନ୍ତି ମୁଁ ତାହେଲେ ତାଙ୍କୁ କହିବି ଆଡ୍ କରିବା ପାଇଁ
ହଁ ମତେ ଟିକେ
ହଉ
ଆପଣଙ୍କ ନମ୍ବର ଟା ବି ଟିକେ ଦେଇଥାନ୍ତୁ ପ୍ଲିଜ
ହଁ ମୋର ହେଲା 73
73
270
270
58
58
230
230 ओके थैंक
ହଉ
यू
ଦେଖେ କିଏ ଅଛନ୍ତି ଆଡମିନ୍ ରେ
बुक ଆସିଲାନି କି ଆପଣଙ୍କର
ହଁ ମୋର ଆସିଛି କଣ 5ଟା ଆସିଛି
ଆଚ୍ଛା
5ଟା ବୁକ୍ ଆସିଛି
ଆଚ୍ଛା କେବେ ଆସିଲାଣି କେବେଠୁ
ଆସିଲା ଏଇ 10-12 ଦିନ ହବ ଆସିଛି
ଆଚ୍ଛା ହଉ
ହଉ ମୁଁ କୋଉଠି ଆପଣଙ୍କ ସେଣ୍ଟର କୋଉଠି ଅଛି ଏକ୍ଜାମ ସେଣ୍ଟର
ମୁଁ କହିଲି ଗ୍ରୁପ ରେ ଯିଏ ବି ଆଡମିନ୍ ଅଛନ୍ତି ନା ମୋର ଏକ୍ଜାମ ସେଣ୍ଟର ବିଜେପି କଲେଜ
ହଁ
ଆପଣଙ୍କର
ଷ୍ଟଡି ସେଣ୍ଟର ସେଇଟା ଯେ କିନ୍ତୁ ମୋର ଏକ୍ଜାମ ସେଣ୍ଟର ଟା କେନ୍ଦ୍ରାପଡା ଦେଇଛି
ଆଚ୍ଛା 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 ନା